vale, no, pues si la puedes igual hacer en castellano, nosotros se la y entiendo.
Que, bueno, yo le pregunté por el tema de mi tesis, que era si era correcto poder utilizar una escala del desarrollo infantil temprano.
Pero la comparación, ¿cuál es el objetivo de la comparación?
Para tener una variedad de criterios.
Ah, la variedad.
Y me dijo que era solamente una correlación lineal.
¿Una correlación, no? Sí.
Igual como que...
Claro.
Como que quedé un poco colgado porque... O sea, eso lo leí en otras partes. Pero en otras partes también eso lo definen como variedad de criterios, en otras partes como construcción.
Criterio convergente. Es que tienen muchas, como él ha dicho, hay muchas cosas que tienen distintos nombres y es lo mismo.
Pero la gente de repente hace la separación, entonces a la hora de yo hacer la separación, explicarla, no me quiero arrancar.
Lo puedes colocar en el caso tuyo como variedades de criterios convergentes, claro, porque van en la misma dirección. Pero porque puede ser también divergente, que van en la dirección opuesta.
Sí. Pero dentro del constructo, dentro de la variedad de constructo.
Bueno, bueno, sí, es un tipo de validez, por supuesto que sí. Yosiana, me falta Yosiana y Gladys, ¿no? A ver, explica yo. ¿Ah?
Sí, bueno.
No, Tatiana, no, ¿cómo se llama? Tania. Hay que firmar la lista de asistencia que estoy atrás también.
Ya, y luego...
¿Ah? ¿Cierto? Vamos a partir con preguntas, digamos, de lo visto ayer, así que abro, si tú quieres hacer la pregunta.
¿En español?
¿Ah?
¿En español?
En español, y Luis pasa y hemos comenzado entonces la sesión de hoy con preguntas sobre el temario de ayer. Va a preguntar en español y yo, si no entiende, yo traduzco.
Bueno, mi pregunta es respecto a los tipos de validez que existen. ¿Ya?
What type of validity that exists?
What type of validity?
Yeah.
Lo que pasa es que en algunas situaciones se clasifica la validez de
In
constructo
some occasions, the construct.
y de criterio como lo mismo, y en otras partes hacen la división.
Okay. In some cases, construct validation and criteria validation are defined as the same, and in some other occasions are different.
Yeah. "50 years ago,
50 años. Bueno,
we talked about 3 types of validity: content validity, criterion validity, construct validity. And then those were broken down. So for criterion validity, there was concurrent criterion validity, predictive criterion validity. For construct validity, there was convergent validity, discriminant validity, divergent validity. We've gotten rid of all of those terms.
ya no existe más.
Now, all of validity is considered to be construct validity.
Todos los tipos de validez son considerados como constructos. Era esa separación, dijo inicialmente, que estaba hace 50 años atrás que ya no existe.
There are different ways of demonstrating construct validity, but there are not different types of validity.
Huh?
So, construct validity means that you have a hypothesis about the way the scale should perform, and you test that hypothesis. So any study that tests the hypothesis about how the scale should perform is construct validity.
¿Queda claro eso?
Sí.
¿Ah? ¿Sí?
So if we hypothesize that the new scale should correlate with an existing scale, that's construct validity. We would have called it criterion validity, but not anymore. Now we just say that's construct validity.
Wow.
Makes life much, much easier.
En el libro que él tiene está claramente explicado eso que ya no existe. Entonces, his master thesis is related to one scale. Y entonces hay que revisar bien el libro para que tú lo puedas justificar.
Claro.
¿No? Lo que pasa es que todavía hay gente que piensa a la antigua.
Es que todavía incluso salen artículos.
Hay artículos que todavía, there are some articles that still use the same terminology.
Probably in medicine, not in psychology. Psychology just uses the term construct validity.
Ellos son los primeros en esto.
¿Está claro?
Muchas gracias.
¿Alguna otra pregunta? ¿No?
No.
Claro, el caso tuyo, digamos, es prácticamente la validación y podrías usar la metodología de las ecuaciones estructurales. Es lo más poderoso, la herramienta más poderosa para tu tesis.
Es muy complejo.
Y la más publicable también. Ok.
Good.
¿Estamos listos para partir? Entonces, si repito, si es necesario parar para hacer algún tipo de traducción, indíquenlo, porque Gladys me dijo ayer de que pareciera, ella tenía la sensación de que era necesario, a pesar de que ella dijo yo entendí casi todo, pero me parece que mis compañeros, entonces a lo mejor mis compañeros se refería a ella misma, no sé.
Okay. If you have questions after I go and you want to write to me, this is my email address. And as I said, you could write in English, Spanish, Hebrew, or Yiddish. Yeah. Okay.
Or in statistical language?
No.
No?
No.
Not allowed?
No. You could write, but I won't understand.
No computer language neither?
No. So what we will discuss today are the limitations of classical test theory, the new rules of item response theory, and then different steps in item response theory: calibration and estimation, the statistics of item response theory, different IRT models, fit statistics, and why we don't see more of it. Classical test theory has dominated test construction for the last 100 years. And the reason is that the assumptions that we make in classical test theory are very weak. Weak meaning they're easy to meet, and if you don't meet them, no big problem. So the assumptions in classical test theory are that for each item, the error score is uncorrelated with the true score, and the average of all the error scores summed over all of the items is 0. Now let me stop. Has everyone had a course in test theory? Yes? No. So you don't know what a true score is in test theory? Okay. Let me back up and introduce a little bit of classical test theory. In classical test theory, anytime we get a score on a person from a paper and pencil test, stepping on a scale, blood pressure reading, whatever, any sort of score that we see is made up of two parts. There's the true score, which we never see, and some degree of error. So the observed score is a combination of true score and error. In fact, the term true score is a bad choice of terms. It simply means the score that we would see if there were no error. If we could administer the scale an infinite number of times so that all of the errors cancel out, we would see the true score, but we never do. So the important point to keep in mind is that every score that we see has some degree of error associated with it. And what this means is that the error is unrelated to the true score. Sometimes it could inflate the true score, it could inflate the observed score. Sometimes it could decrease. In the long run, all of the errors would cancel out and they would have a mean of 0. Is that clear? If these assumptions hold, then reliability increases with the length of the scale. The more items there are, the greater the chances that the errors will cancel out so that the score becomes more reliable. The second assumption is that as the items become more correlated with one another, the reliability will increase. But there are problems with what's called classical test theory. First, if we validate the scale, develop norms on the scale, those norms, the statistics that we derive for the items and the scale as a whole, pertain only to that group. And it's affected by the homogeneity of the group. If the group is extremely homogeneous, then the reliability of the scale decreases. And we'll go over this later. And if we alter any of the items, we have to go back and reestablish the norms for the items and the scale. Okay?
La gente decidió seguir nomás y hacer preguntas en español. a raíz del comentario que tú me hiciste.
A second problem is what we call circular dependency, that the scores that we derive when we validate, when we norm a scale, depends on how much of the trait the people have. But how much of the trait the people have depends on the scale. So we're going around in a circle.
¿Se entiende eso? ¿Es necesaria una explicación a eso? ¿Eso es importante?
Para procesar el grupo.
Sí. Lo que pasa, ¿no es cierto?, de que los puntajes que generalmente se puede generar con la escala dependen de la magnitud del constructo que se desea medir. Entonces, si tú tienes grupos que son muy homogéneos, entonces obviamente el rango de variación de la escala va a ser también pequeño y por lo tanto las propiedades, digamos, de la escala se van a ver desmejoradas. Desmejoradas, claro. Por eso tú tiene que ver después con cómo seleccionar los sujetos. Tiene que tener sujetos que tengan una gran variabilidad de lo que tú pretendes medir, de modo tal de que eso se refleje después en el score. Porque tú en el puntaje finalmente tú vas a decir los que tienen más puntaje es por lo que tienen más cantidad de esto que yo quiero medir. Y los que tienen menos puntaje son los que tienen menos cantidad de esto que yo quiero medir. A eso se refiere.
A third problem is that it assumes that all of the items are equivalent. That if we have a scale with 10 items, that all of the items contribute equally to the total scale. And that the sum, the total score, is simply what we get when we add up all of the items.
David, can you expand a little bit, because sometimes people is to make just the parallel when they do component analysis to create a score and use the weight or the coefficient that produces the component analysis.
Yes.
What is that compared to this? Because in this case you don't have any weight.
That's right.
Okay? ¿Entiende la pregunta? Que lo que muchas veces uno construye puntajes usando, ¿no es cierto?, tiene un conjunto de variables que le aplica, ¿no es cierto?, análisis de componentes principales, y con el análisis de componentes principales tú generas un puntaje y los pondera, digamos, según los coeficientes que te da la metodología. En cambio aquí él dice, ¿no es cierto?, todos los ítems valen lo mismo.
The reality is that the weights don't help.
Las ponderaciones no ayudan, ¿eh?
Many years ago, Howard Weiner wrote an article called On Estimating Coefficients and Linear Regression. It don't make no never mind. What he showed is that if you have a multiple regression with 10 or more predictor variables, you get the best prediction if you use the beta weights. But if you change the beta weights, replacing all of the low beta weights with 0, all of the high beta weights with 1, you get just about the same answer. That if you have at least 10 predictors, the weights add very, very little. A scale is the same thing. Each item is like a variable in a multiple regression. So you could use the weights, but in reality, the correlation between the weighted version and the unweighted version will be above 0.95. So the weights don't help. They just make it more difficult to score the test.
Sí, ¿no es cierto lo que dice que si tú usas ponderadores, finalmente el score final no va a variar mucho del score final obtenido con los ponderadores? Y yo quiero agregar algo más, porque más encima si tú estás produciendo, ¿no es cierto?, tienes una escala donde, qué sé yo, la gente, por ejemplo, en la atención primaria quiere calcular un puntaje para ver, digamos, qué tan bien, qué tan mal. Si más encima de eso le agregas que este hay que multiplicarlo por 0.43 más el otro por 0.38, es un desastre, ¿no? Un desastre. I was telling them, even if you want to use it in real life the scale, if you tell the physician to wait and to produce the score, it will mess everything up, right?
Yes, absolutely. There is a scale called the Schedule of Recent Events by Holmes and Ray. And it consists of many, many different things. Getting a parking ticket, buying a new house, becoming sick, your spouse dying. And you check off which ones happened in the last 6 months. And each of those gets a weight. So that a parking ticket has a weight of 10 points. Death of a spouse has a weight of 100 points. And it makes sense on an intuitive level that there is much more stress associated with the death of a spouse than with getting a parking ticket.
¿Se entiende el ejemplo? El ejemplo dice, ¿no es cierto?, que construye una escala con eventos negativos de la persona. Entonces un evento negativo fue que te sacaron una multa. Te pararon los pacos y te sacaron una multa. Otro evento negativo es que ha sufrido la muerte, en este caso, de su pareja recientemente. Y tiene una serie de eventos negativos que quiere sumar, digamos, qué tan mal está, qué tan nivel de estrés tiene la persona. Obviamente que ahí no es lo mismo ponderar la multa con la muerte de tu pareja. Entonces pudiera en esos casos tener el ticket 10 puntos de ponderación, pero la muerte de la pareja 100 puntos. ¿No?
Yeah. So we gave the test to a large number of people. And we scored the test 3 different ways. We used the weights that Holmes and Ray assigned, 10 to 100. We used weights of 0 and 1. If the event occurred, it had a weight of 1. If it didn't occur, it had a weight of 0. And the third way was that we made up weights at random.
¿Entiendes? Que hicieron, aplicaron tres tipos de ponderadores, ¿no? Uno en cada evento que lo ponderaran de 0 a 100, otro en cada evento fuera 0 o 1, dependiendo si estaba presente o ausente, y el tercero asignar ponderadores totalmente al azar. Al azar.
The correlation among the 3 versions was 0.99.
¿Está claro, no?
Weighting doesn't help.
Entonces, ¿hay que ponderar? Okay, thank you.
Okay.
Sí.
Por ejemplo, el score de mortalidad por neumonía.
The pneumonia mortality test.
Se pondera de diferente forma cada uno de los ítems, dependiendo de la severidad, digamos, o del mayor riesgo que el niño tiene de morir por neumonía. Por ejemplo, un niño que tiene el antecedente de una malformación congénita, por ejemplo, presenta 11 puntos respecto de un niño que es hijo de una madre adolescente y solamente se le asigna 2 puntos o 3 puntos.
Did you follow? No, there is tú me corriges, there is a scale for pneumonia, but the scale, it depends on the on the children stage, or the mother stage. ¿El primero cuál fue? ¿Ah?
¿Te ayudo yo?
¿Cuál fue el primero?
La presencia de malformaciones congénitas.
Dale, yo sé.
There is a score to measure the possibility or the risk of death of the children. So there, for example, different weights of each event, and childhood malformations that score higher than having a teenage mother. ¿Cuál es la pregunta?
No, lo que yo entendí, espera, es que no, yo entonces entendí mal, yo entendí de que la escala era como distinta dependiendo de esa condición.
No, si yo conozco la escala.
¿No?
Lo que pasa es que en este caso se pondera, pero no es tan complicado como multiplicar cada resultado por un factor diferente, sino que ya viene estipulado que la presencia de cada uno de los factores
es como tener una escala separada dependiendo de la condición de llegada, entonces.
Los puntajes se van sumando.
Okay, go ahead.
So it's
So
a
each
score.
item, yeah.
So each event
Has a score, right,
certain score.
weight,
And
yeah.
the final score
Is-
determines the risk of death of
Right.
the child.
Right.
So she wants to know why in these cases that shall be ponderado,
Weighted.
that shall
Wait.
be weighted, or why in this case that is weighted and in others not.
Have you ever tried the scale without the weights?
¿Han probado sin ponderar?
Yeah. It is quite possible that the scale will work just as well if you don't use weights.
Dice que es bastante probable que funcione igual si no pondera. Pero yo pienso que pareciera ser de que la escala es dependiente del tipo de, por decirlo, en diferentes poblaciones. En este tipo de población tengo que usar esta forma, en este otro tipo de ponderación de población tengo que usar esta otra forma. Puede ser que sea así.
No, lo que pasa
No lo
es que
sé.
esa escala es una escala de riesgo de morir por neumonía. It's okay. Shall I speak Spanish or English? Do you understand Spanish?
A little bit.
tell it both ways.
Okay.
Entonces es una escala de riesgo de morir por neumonía y se hizo un estudio grande en el cual se determinó se identificaron los factores de riesgo para población chilena. Entonces, en base a esa población se ponderó el riesgo, ¿ya? Y de acuerdo a todos los factores de riesgo es como la escala de Framingham. Entonces se va puntuando el riesgo de acuerdo a la presencia de ciertos factores, ¿ya? Entonces,
pero que eso suena más como si fuera un modelo predictivo que como una escala.
exactamente, es un modelo
Es un modelo
predictivo.
se predicted more than a scale, I guess.
Yeah.
Because
It's like the Framingham scale,
Right.
where you have to measure the risk based on certain
Yeah.
events that are present or not, and those have
Weights, yes. I would suggest if you have the data, use the scale as it's made with the weights, but also substitute the weights. That if the person doesn't have that risk factor, the weight is 0. If the person does have the risk factor, the weight is 1. And see if there's any difference between the two predictive equations. I would guess that the equations will come up with very, very similar predictive scores.
Equivale a como tener una variable que tiene, estas son las condiciones, ¿no? Y poner en un modelo de regresión cada una de las condiciones como si fuera una variable dummy, 0, 1, 0, 1, ¿no? Entonces si tiene esto, 1, entonces después lo demás va a ponderar, por supuesto. Si tiene esto, 0, entonces no va a ponderar. Yo creo que sería, si tiene los datos, dice, sería un buen ejercicio hacerlo y yo te puedo ayudar. Sería interesante. ¿Tú los tienes los datos?
Estaba mirando la escala ahora.
Ah, ya, pero no tienes datos.
Los datos sí se pueden obtener.
Ya, listo. Yo creo que puede ser un lindo ejercicio, hagámoslo.
¿Ahora? No.
No, ahora no.
by 10 o'clock.
Al coffee break.
The coffee break.
Pero luce más como un modelo predictivo.
Sí, pues es un modelo predictivo para...
Es un modelo predictivo
para
porque al
medir el
final está
riesgo.
midiendo una probabilidad, la probabilidad de morir.
Sí, pues,
Claro.
sí, eso es.
Es un modelo predictivo, más que una escala. Porque la escala, digamos, es cuánto más de esto tiene, ¿no? Y aquí muere o no muere. ¿No?
O sea, es un modelo predictivo que se usa en los centros de atención
Sí, claro.
primaria para determinar
Claro.
qué conducta se va a seguir.
Claro, entonces incluso ahí es distinto. ¿Por qué es distinto? Porque tú, cuando construyes un modelo predictivo, finalmente tienes que determinar, decir cuáles son las propiedades del modelo predictivo. Tienes que decir sensibilidad, especificidad, valores predictivos positivos, negativos, etcétera, para poderlo usar. Es otra cosa. I was telling that in the predictive model, you ended up finally computing sensitivity, specificity, positive predictive values, and so forth, which is a different way of...
Yeah. Yeah. Sensitivity, specificity, those are for dichotomous predictors.
Yeah, because it's risk of dying.
That's a probability.
It's a probability. But the outcome is die or not dying.
No, el outcome es la probabilidad.
No, el
Yeah.
outcome finalmente es la muerte, para poder
Ah, sí,
construir
pues.
el modelo.
Yeah.
Claro.
Yeah.
Y tú con las determinadas condiciones estimas la probabilidad de morir. Podría ser 0.3,
Sí.
podría ser 0.98.
¿Entiendes por qué es diferente una escala?
Sí, sí, no sé, no entendí. Lo que pasa es que la combinación y el...
Bueno.
Como se me viene a la mente. Bueno,
No, pero está interesante, podemos hacer el ejercicio. Okay.
Okay.
Are you confused now?
Totally.
Okay.
Totally. Adding up the items also assumes an interval scale of measurement. That if we have a Likert scale, does everyone know what a Likert scale is?
Escala Likert, ¿no?
Anyone who doesn't?
Todo el mundo sabe.
Okay. That the divisions are equally spaced. We have to make that assumption in order to add up the different items into a total score. And we know it's not correct.
Sí.
Okay.
Respecto a lo que estaba diciendo de que en una escala Likert que tiene 5 puntos, por ejemplo, finalmente si uno puntúa 3 aquí, 4 acá, 1 acá, lo que hace finalmente es suma y asume que no hay ninguna diferencia. El otro supuesto es que también tiene la escala Likert cuando se usa como número, es de que la diferencia de un señor que puntúa 4 con uno que puntúa 3 es lo mismo que el que puntúa 2 con aquel que puntúa 1, que no necesariamente es válido.
Another problem with classical test theory is that we have a standard error of measurement. Does everyone know what a standard error of measurement is? It's like a standard error of the mean, but applied to a score on a scale. It's how much we expect the score to change from one administration to the next. In classical test theory, we assume that the standard error is the same throughout the entire test. Too many buttons. Like that. Where these are the scores and this is the standard error. And we know that's not true. We know the standard error is actually like this, that it's much smaller in the middle of the test than at the ends. The same thing that we see in a regression line, that the standard error is smaller in the middle where there are more scores. And at the extremes where there are few scores, the standard error is larger. We know this is the case But in classical test theory, all we could calculate is that. Okay? We have problems equating tests. So, for example, in one study, we are following children over 5 years. And as they reach the age of 16, we have to switch from a child version of the test to an adult version of the test. And we're assuming that a score of 80 on the child version is the same as a score of 80 on the adult version. We're assuming the tests are parallel. But we don't know that. It's very hard to establish that in classical test theory. We sometimes try to equate tests by converting the score to a T-score or a Z-score in Canadian English, a Z-score in American English. But that assumes that the scores are normally distributed. Okay? Okay. So, Embritson wrote a very influential article about item response theory. And she introduced new rules of tests. The old rule, as I said, is that the standard error of measurement is the same for all scores. In item response theory, the standard error of measurement is different for the different scores, but it generalizes across populations. Okay?
Sorry, can you explain what it means that it generalizes across populations?
That if we have different groups of people, all those groups will have the same standard error of measurement. Males and females. Spanish-speaking indigenous populations. Okay? In classical test theory, longer tests are more reliable than shorter tests. The new rule is that we can make shorter tests that are just as reliable or even more reliable than longer tests. Old rule is that if we compare tests across populations, we have to be sure that the tests are parallel or that we've equated them in some way. With item response theory, we could compare scores of people when the test difficulty varies. Let me give an example. There's a test, bless you. There's a test of verbal intelligence called the Peabody Picture Vocabulary Test. It consists of a booklet. Each page on the booklet has 4 pictures. And the examiner says a word, and the person has to point to which of the 4 pictures defines that word. This test was developed using item response theory. So I can take a young child, a 5-year-old child, and give items from the beginning of the test. I can take an adult who has mental retardation and give items from the middle of the test. I can take someone who is a university professor and only use items from the end of the test, so that those three groups never take the same items. But because the entire test was developed with item response theory, I can compare the scores across those different groups. Is that clear?
Respecto a lo anterior, que las pruebas cuando son más cortas pueden ser incluso más confiables que las largas, y eso se aplica tanto para las pruebas clínicas como para la investigación.
He's asking whether the shorter versions are more reliable than larger.
They can
Even
be.
in clinical tests or in clinical or
En investigación,
or in research.
They can be, in both.
y respecto a la regla número 3, la consulta es que si uno está construyendo un test con algunos parámetros de la población,
¿Qué quiere decir eso?
¿Mm?
¿Qué quiere decir con algunos parámetros de la
O
población?
sea, me refiero a que, o para alguna población en particular, es como, o sea, uno como, no como investigación, como clínico, siempre va a ver cuándo puede ocupar la prueba o no, si está adecuada, si es como...
¿Cómo saber a qué población aplica el test?
Es que me refiero al clínico, siempre va a saber cuándo ocuparlo o no. Por ejemplo, él da el ejemplo de las personas con retraso mental, ocupaban hasta la mitad, ¿cierto? De
Una
puntaje
sección.
del medio. Y cuando se lo aplicaba a un profesional, ve los puntajes finales. Pero eso es como obvio, ¿no?
No es tan obvio porque yo creo que lo va a explicar más adelante cuando defina qué es lo que es la teoría de respuesta al ítem. Yo creo que por ahora está un poco nebuloso todavía. Sí, esperemos un poco a ver si se aclara o si no volvemos a la pregunta.
Ya.
Okay.
In classical test theory, if we want unbiased estimates of the statistics about the test, we need a representative sample. We don't in item response theory. We can use unrepresentative samples and still get unbiased estimates about the scale. Okay, let's forget about it. Okay, so what is item response theory? It's actually a family of different models, and they are latent trait models. As we discussed yesterday, we remember what a latent trait is? Okay, we don't see it. We assume that what the scale is measuring is a latent trait, and that the items are the observed manifestations of that trait. Okay? And there are two hard assumptions. Hard because if we violate them, item response theory doesn't apply. The two hard assumptions are unidimensionality and what we call local independence. Unidimensionality means that the scale is measuring only one attribute. It seems very straightforward, but it's actually a very difficult concept. For example, is anxiety unidimensional or multidimensional? And the answer is yes.
Yes.
Yes. If I were developing a scale to be used in a physician's office, where the physician can simply give it to the patient and say, is the patient sufficiently anxious that I should refer the patient to a psychologist or a psychiatrist? In that situation, I would say anxiety is unidimensional. If I were developing a scale to be used in an anxiety disorders clinic, then I would say no. Anxiety has 4 different components: an affective component, behavioral component, cognitive component, physiological component. And in the clinic, it's important to differentiate among those different components, because someone in treatment can show improvement in some of those, but not in others. So here I would say anxiety is multidimensional. So it's not an all or nothing thing. It's unidimensional enough for my purposes. Is that clear? No. No.
¿Se entiende?
What do you mean with enough for your purposes? I don't get that 100%.
It means it's a subjective judgment that even if the anxiety scale is somewhat multidimensional, if I were developing it for a physician's office, I would say I could ignore the fact that there are different factors.
Okay. So then it means that you can use it only in that environment.
That's right.
Not in another.
That's right. Because I'm developing a scale where I'm assuming that anxiety is unidimensional. And it's usually tested with exploratory or confirmatory factor analysis. And in exploratory factor analysis, is the first eigenvalue, and here there's a debate, 3 times larger, 5 times larger, 10 times larger than the second factor? Again, it's a judgment call. In confirmatory factor analysis, does a unidimensional model fit well enough? Okay?
So in that case, you put all the items as independent. You don't.
No, not independent. In one factor.
In one factor, you,
Yes.
you don't have any dimensions.
No. No.
Just put the list.
That's right. And even if there are other factors, if the one-dimensional model fits, it should be sufficient. Local independence means that the probability of endorsing an item is affected only by the amount of the trait. And that if we remove the effect of the trait, all of the items are independent from one another. This is probably easiest to define if I give some examples where this is violated. When I was in graduate school, we had to take a foreign language exam. And the test that they gave consisted of reading a paragraph in German and then answering 5 questions. Reading another paragraph, answering 5 questions, and so on. Those 5 questions violated local independence. Why? Because if I understood the paragraph, I could answer all 5 questions. If I didn't understand the paragraph, I couldn't answer any of the questions. So the questions were not independent from one another. If there are 2 questions like, I can walk 5 miles and I can walk 1 mile, they're not independent. If you say yes to I can walk 5 miles, then you know with 100% probability what the answer will be to I can walk 1 mile. Yeah? If you ask the same question 2 or 3 different ways, those items are not locally independent. Okay. Let's forget about this. Is detail. Okay. What we have to do in item response theory is what we call calibrate the items, estimate the difficulty level of each item. The terminology in item response theory is a little bit complicated because it arose from education testing, ability testing. So the probability of answering a question is called the difficulty level. Now, this makes sense if we're testing someone's ability in mathematics. An item on solving a quadratic equation is much more difficult to answer than adding 2 numbers. It doesn't make as much sense in personality theory. It's just as easy to answer an item, I feel sad, as I'm going to kill myself. But what we mean by ability is how much of the trait the person has to have in order to endorse the item. So if we're measuring depression, the person has to have much more of depression, much more of the trait to endorse the item, I am going to kill myself, than to endorse the item, I sometimes feel sad. So I am going to kill myself is a much more difficult item than I feel sad. Okay? So difficulty is a bad choice of terms, but it's what we have. Any questions so far?
Lo que está diciendo es que una de las resultados de aplicar la teoría es que te va a dar la dificultad de responder a cada ítem, a cada pregunta. Ese va a ser uno de los resultados de la aplicación del método. Esa es una cosa. Para tenerlo en cuenta, ¿no?
And in the same way, ability simply means how much of the trait the person has. Even though ability is a bad choice of terms, if we're talking about anxiety or depression or extroversion or whatever. But ability simply means how much of that trait do you have?
¿Se entiende eso?
May I ask, what is exactly the difference between difficulty and ability?
Difficulty applies to the item. Ability applies to the person.
Okay.
Otra forma de poder decir eso es, suponte tú en una escala de calidad de vida. Entonces dice una escala de calidad de vida, ¿en qué se refleja que haya personas que tienen buena calidad de vida o mala calidad de vida? Eso se dice endorse, la habilidad de endorsar. ¿Cómo se dice endorse en inglés? Endorse, ¿no?
Yeah.
¿No? ¿En qué se refleja que gente tenga buena calidad de vida y en qué se refleja gente que tenga mala calidad de vida? Va de la persona al ítem, ¿no? Eso es lo que está, es lo que llama ahí la ability. En cambio en el otro, digamos, es la probabilidad, digamos, de que la persona pueda responder a ese ítem. Son las dos cosas que uno mide, digamos, cuando usa la metodología.
Okay. So let's start off with a matrix. These are 5 items as answered by 5 people. 1 means the person endorsed the item. 0 means the person did not endorse the item. For the item difficulty, we count the number of failures. So this item was failed 60% of the time, or was not endorsed 60% of the time. So it has a difficulty level of 0.6. This person endorsed 2 items. So this person has an ability level of 0.4. Okay? So we say that person 4 tentatively is considered to have an ability level of 40%. Why do we say tentative? Let's take these 3 people. Each person has an ability level of 0.4. But each person endorsed different items. So this person endorsed items with a low difficulty level. Okay? This person has an ability level of 40%, but based on difficult items, and this person is split. So we have to modify our estimates of the person's ability level dependent on the difficulty level of the items that he or she endorsed. Clear so far? Similarly, item 1 has a difficulty level of 80%. That's tentative. Why tentative? Because let's take these 2 items. They both have a difficulty level of 80%, but based on people with very different levels of ability. So we have to modify the difficulty level on the basis of the ability level that the person had. So it's a circular thing, that we have to modify the difficulty based on the person's ability. We have to modify the ability based on the item's difficulty. Yes?
Are there any ideal ratio, that difficulty, ability?
I'm not sure what you mean.
If, let's say...
Rule of thumb.
Yeah,
For what?
For the,
What would be
the
good?
proportion or the ratio of ability and difficulty?
No, we'll see how we use both of them in a minute. Both of them are independent and important. So, as I said, we have to consider the item difficulty and the person ability in order to calibrate the items and estimate a person's ability level. And it's an iterative process. Don't be scared by this. It's actually very simple. The probability of endorsing an item is given by this equation. That the probability is 1 over 1. Does everyone know what E is? 2.71828. It's just an irrational number. Raised to the power, looking at the difference between ability and difficulty. And what this produces is what's called a logistic function, which we'll see in a minute. So the probability of endorsing an item is the difference between the person's ability and the item's difficulty. Both are measured on the same metric, like a Z-score with a mean of 0 and a standard deviation of 1. If the person's ability is equal to the item's difficulty, then the probability of endorsement is 50%. Okay? If the person's ability level is greater than the item's difficulty level, then there's a higher probability. And if the ability is less than the difficulty, the probability is less than 50%. Is this clear so far? Okay. So, if we remember the original matrix, for person 1, item 1, that person had an ability level of 1, that person answered all of the items, and the item had a difficulty level of 0.8. If we put those numbers into this equation, we come up with a probability of 0.55. Since the person's ability is greater than the difficulty, the probability is above 0.50. Is that clear? So, what we have from the first iteration, we've taken for each person, each item, we've put those numbers into the equation and come up with the value. Yeah? So we just did this cell, where the person had an ability of 1 with a difficulty of 0.8. We figured out the probability of endorsement is 0.55. And again, where the ability level and the difficulty level are the same, probability is 0.5. So now we have to revise the estimates of the ability and the difficulty until there's no discrepancy. So that was the original matrix, and then we put all of the numbers through that equation and we came up with this matrix. Now we take these numbers, which are up here, put them through again, and we come up with a somewhat revised estimate. And we keep on doing that until there are no more changes. And then we have a good estimate of the difficulty for each item and the ability for each person. Okay. So the ability level, the amount of the trait, we denote with the Greek letter theta. And as I said, theta is similar to a z-score with a mean of 0. The average person has a theta score of 0. That means an average ability. Like a z-score, it theoretically ranges between minus infinity and plus infinity, but for all practical purposes, it's between minus 3 and plus 3. Okay? Now we come to the fundamental unit, fundamental thing that we concentrate on in item response theory, which is called the item characteristic curve. And the item characteristic curve shows the relationship between the trait and the probability of endorsing an item. So every item has an item characteristic curve. And as I said, from that equation we get a logistic function. Why a logistic function? When this theory was first proposed, a somewhat different type of scaling, Gutman, who was the person who proposed it, said there's a step function, that the probability of endorsing is 0 until you reach the person's ability level, and then it jumps to 100%. Okay. Problem is, it's deterministic. It doesn't allow for any errors. The correct distribution that should have been worked with was the cumulative normal distribution. You all know what a normal curve is. Instead of plotting the level, you plot the cumulative level. Okay, so it's always growing. The problem was that item response theory was developed in the 1960s, before there were desktop or laptop computers. And it was very difficult to work with the cumulative normal distribution. It involves integrals with infinite limits and so on. And it's much easier to do the mathematics using a logistic function. And in fact, the two are very, very similar. So there's no real difference. And that's a logistic function. Okay?
How do you interpret that?
I interpret it as a very pretty blue line. The interpretation is that it's the probability of endorsing an item given the person's ability level. Okay? So if the person has an ability level way, way down, the probability of endorsing this item is 0. Person has an average ability level, then the probability of endorsing this item is about 0.25. Okay? And as the ability, as the theta increases, the probability of endorsing the item increases.
So how do you know whether this item is a good item or not?
A good item, we'll get to that in a minute.
Okay.
Okay. So the difficulty level for the item is where the probability of endorsement or answering correctly is 50%. And that's also where the slope of the curve is maximum, and that's called the item's difficulty level. So here we have two items. That should be exactly at 50. Why isn't it? Because it's Microsoft. And Microsoft doesn't do anything well. If that were at the 50%, it crosses item 1 over here, so we drop a line down, and that corresponds to a theta of 0.2. Item 2 has a difficulty level of 0.7. So we could say both items are near the middle, and that item 2 is somewhat more difficult to answer than item 1. Clear?
May I ask something?
No. Okay. Yeah, go ahead.
Sí, porque para que quede grabado.
If this is different than item response theory, I understand that each question is kind of independent from the others.
That's right.
So how do you know how many questions you need for measuring, let's say, anxiety or something? How you determine the amount of questions that you need in a test or in scale or...
Okay, that's a very good question. Again, it depends on the purpose of the scale. If I were developing a scale to be used in the general population, to be used by people with no anxiety and people with a very high level of anxiety, I would start off by choosing items across the whole span of the theta scale. So I would have some very easy items, middle items, more difficult and very difficult items. If I were interested in developing a scale to be used by physicians to determine if they should refer a patient to a clinic, I don't care about discriminating down here. I don't care if the person has absolutely no anxiety versus a small amount versus a moderate amount, whatever. I'm more interested in items in this range. Does the person have enough anxiety to be debilitating? So I would construct the scale by choosing items near the cut point. Similarly, I'm not interested in making fine distinctions up here, because if the person has high anxiety, I, as a general practitioner, don't care how much. All I care about is that the person has enough that I have to make a referral. If I were in the clinic, I would have a lot of items here, because in the clinic I'm interested in the degrees of anxiety. Everybody in the clinic has anxiety, and I want to know how much and is the person improving. So I can very easily tailor the test, the scale, to meet the demands of what I'm trying to do. Also, I can take a scale as has been done with the geriatric depression scale. It's a long scale, and it's difficult for elderly depressed patients to fill out because there are so many items. So I can use item response theory, and we'll see this later, to eliminate redundant items. If there are two items with the same difficulty level, I don't need them both. The second item isn't giving me any new information, so I can throw it out. So I could end up with a much shorter scale that has the same reliability, and I would check for reliability in the usual way.
It all depends.
It all depends, absolutely. That's true with everything in life.
It's like the example of the, I don't know if you're familiar with the test for medication adherence, the Morisky and Green Levine.
No, no. Tell me about it. Yeah.
It's very simple. It's a 3-question test to see whether the patient adhere or not adhere to hypertensive or cardiovascular medication. So it consists of 3 questions. And whether you answer all of them positively, you adhere or not. So it's the outcome is
dichotomous, yeah.
That should be an example of item response.
I don't know. I don't know how the items were chosen.
Okay.
Item response theory refers to how the items were tested and chosen.
Okay.
So if you look at a scale, you can't determine if it was developed using classical test theory or item response theory. The scale would look identical.
Oh, okay.
You'd have to look at how the scale was developed and what the psychometric properties are.
Okay.
How long do you want to go?
Coffee break?
Absolutely, always.
Okay, coffee break. Great. 5:12. Break.
Yeah.
La mayoría
is to see how each influences the outcome.
Yeah. Yeah.
Oh,
That would be a good way. Okay.
Thank you. Es que le pregunté si podíamos construir un modelo de ecuaciones estructurales con todas las variables que tomamos en el primer folio y que ahora explorando en forma separada cada una, y me dijo que sí. Entonces yo le pregunté que quién podría hacer y me dijo que él. Sí.
¿Está dispuesto?
Sí.
Okay.
How many pisco sour are you going to charge for that particular?
How high can you count?
Oh, my pisco sour is quite good.
Very good one.
Excellent. Okay. Let's discuss some more about item response theory and look at the item response function. This is the same equation that we looked at earlier, except instead of theta, we wrote ability, and instead of B1, we wrote difficulty. So it's the same equation. And this is called the one-parameter logistic model. In the one-parameter logistic model, the only difference between items is their difficulty level. Okay? So you could see that the letter for difficulty, B, has a subscript. So that means that each item could have a different value for the difficulty. There's also a parameter for discrimination, which we'll discuss in a minute, but it doesn't have a subscript. So that means that all of the items are assumed to have the same discrimination. The items differ only in difficulty level. So if we're talking about the one-parameter logistic model with dichotomous items, it's also called the Rasch model. So you may see the term Rasch model. That's synonymous with a one-parameter logistic model. Okay, and this we discussed previously, that where theta equals B, 50% of the people will endorse the item. If theta, the ability level, is less than B, fewer than 50% will endorse the item. If theta is greater than B, more than 50%. Okay. Now, note that the discrimination also has a subscript. This means that now each item can differ in two ways from one another. They can differ in terms of the difficulty, and they can differ in terms of the discrimination. So now it's called a two-parameter logistic model. Yes?
How do you define discrimination for this purpose?
I'm glad you asked.
Okay.
Here we have two items that have just about the same difficulty level. They both cross the 50% line at a difficulty level of about 0.6, but their slope is different. Item 2 has a steeper slope than item 1, so it's a better discriminator. There's a sharper discrimination between the answers of people who do and do not have that amount of trait. Okay? That means that if we are developing a scale or trying to shorten the scale, and we find that two items have the same difficulty level, we don't need both items. The second item is giving us no additional useful information. So how do I choose which item to keep? Keep the item with the sharper, the better discrimination. It's a more useful item. There are theoretical problems with the two-parameter model. The item characteristic curves cross each other. So we can't ask a question, which is the more difficult item? Because the answer is, it all depends. Over here, item 2 is more difficult. Over here, item 1 is more difficult. So we can't say which one is more difficult. The answer is it all depends. That violates one of the assumptions of the Rasch model. Is that important? Only if you want to stick with the Rasch model, and we'll talk about that later. Some people say it's very important. Some people say it's not at all important. Yeah.
If you have such difference in two items, how that is associated with the fact that you don't take sample size or sample characteristics into account? How do you know that this difference is not due to the differences in the sample where you tested the question?
Because in item response theory, this information is independent of the sample.
But I don't understand why. How can that be possible? Let's say here in Chile, if you test something among non-educated people or educated people, it won't be probably the same?
The item characteristic curve will be the same.
Okay, so if it's good, it should be.
Yeah.
But when you initially test it, you need to try it in different populations.
You should. Ideally, you should have a range of people. But if you don't, unlike with classical test theory, I can derive some item characteristic curves with a population of uneducated people and a separate population of educated people.
And you can have the same results?
That's right. Now, I may not get meaningful information. If I have a difficult item, none of the people in the uneducated group may be able to solve it, so I don't get any useful information about that item. I will get useful information about items near their ability level. Maybe they could answer a few of the more difficult items, so I'll get some useful information. We'll see that if we ever get to the end. Okay. There is also a three-parameter logistic model. If we go back, let's go back here. In the one and the two-parameter logistic models, if theta is close to 0, then the probability of answering is close to 0. But especially in achievement tests, it may be a multiple choice questionnaire. We see this all the time in math tests or reading tests. And unless you are penalized for a wrong answer, you are told, if you don't know the answer, guess. That's the best strategy. Because if you don't guess, you're guaranteed a 0 on that item. If you do guess, and it's a 4-choice item, there's a 25% chance of getting it correct. So that means that in multiple choice questionnaires or tests, even if theta is -3, you may get a response greater than 0 based on guessing. So the 3-parameter logistic model takes that into account. It's used very rarely in our field. Most of the time in our field, we use either the 1 or the 2-parameter model. Okay, this is the 3-parameter model, where we've added another parameter for guessing. But we'll leave it at that. A little bit of philosophy and theory. At one level, we could see the 3-parameter logistic model as a general model. That this is the 3-parameter model. If we just set C of I to 0, we get the 2-parameter model. And if we simply set A of I to be a constant, we get the 1-parameter model. So at one level, we could say they're all the same. At a theoretical level, they are very different. In the RASH model, in the 1-parameter logistic model, the model is everything. We are seeing, do the data fit the model? And if they don't, we say we can't use item response theory. In the 2 and the 3-parameter logistic model, we adjust the model to fit the data. So the data are paramount, and we fiddle with the equation to match the data. So there's a big difference whether the model is paramount or whether the data are paramount. And strictly speaking, if you're trying to develop an interval-level measurement instrument, you should only use the 1-parameter model.
I don't understand. What do you mean by data paramount? I'm sorry, ignorance.
You? Do you want... You have these data. You've gathered these data about these items. You could ask 2 questions. One is, do these data fit a 1-parameter model? And in that case, the model is paramount. You're asking, do the data fit the model? If they do, fine. Then you can go ahead and develop an interval-level scale. If the data do not fit the model, you stop. There's nothing you could do. Or you could say, I have these data. What is the best way to look at these data? Is a 1-parameter model sufficient? If not, let me try a 2-parameter. If not, let me try a 3-parameter and adjust the parameters to match the data. So the data are the important thing, and the model is secondary to the data.
Okay.
Okay? Up until now, we've talked only about dichotomous items. All of these curves and these models apply to dichotomous items. But we also deal all the time with polytomous items, such as a Likert scale, or a visual analog scale, or an adjectival scale. And in our field, these are probably much more widely used than dichotomous items. In classical test theory, we assume that the steps are equal. But in item response theory, we could actually test, we could ask the question, is the assumption correct? Are all of the options used in the correct order? And are all of the options used? And there are a number of different models. The graded response model is used with categorical responses. Okay? So it's an extension of the two-parameter logistic model, where each item has a single difficulty level, and there are threshold curves. That is the threshold from switching from strongly agree to agree, from agree to disagree, and so on. The advantage of the graded response model in scale development is that not all of the items have to have the same format. So you could develop a scale with 4 response items, 7 response items, dichotomous items, throw them all in together, which you can't do with classical test theory, and use this model. The model that's probably most often used is the rating scale model. It assumes that all of the items use the same structure. A 5-option Likert scale, a 10-option visual analog scale, or whatever. So those are the same for all of the items. And it assumes that the answers are ordered. And it assumes that the categories have the same difficulty level. A strongly agree is the same difficulty for all of the items. Okay. Partial credit model, rarely used in testing attitudes or beliefs. It's more used in multiple choice tests when there's a correct answer, but some of the answers are almost correct. So you could say there's a correct answer, there's a definitely wrong answer, and there's some that, yeah, the kid got the general idea, but not the whole thing right. So they get partial credit for being almost right. There's no assumption of the rank ordering, and each item has a unique structure. It's a very, very general model. You need a lot of subjects because there are a lot of parameters that you're estimating, but it's the most general model. Difficulty with it is that some options may not be chosen by very many people, so you don't have good sample characteristics. And as I said, a lot more free parameters that have to be modeled. And then there's just a generalization of that. Okay. we could get a lot of visual information from item response theory, which I'm a visual person. I understand pictures much better than numbers. So let's take a look at what we would get if we have a polynomous item where all of the options are used and they're very nicely distributed. So what we would get, this is one item, and since we have 5 responses, we have 4 thresholds, the transition points from one response to the next. So that's the threshold between strongly agree and agree. And we could look at this another way. This is the probability of answering any one of those responses given a person's ability level. So as we see, all of the responses are used. Moreover, each of the responses is dominant somewhere along the ability continuum. So over here, strongly agree is the dominant response. Over here, agree is the dominant response. Over here in this range, neutral is the dominant response, and so on. It's also worth noting that, even though it didn't come out this way, the sum, if we add this plus this will equal 1. Because anywhere along this continuum, the probability of giving one of those responses is 1. Let's take a look where not all of the options are used, and the response options agree and disagree don't add very much to the question. So, as you can see, the spacing is very different. There's very little area where agree and disagree are used. And for the agree and disagree options, there's no place where it's the dominant response. Even when agree is reaches its maximum, neutral is still more likely to be answered. Same thing here. There's the greatest probability that disagree will be said, but even at that level, neutral will be more widely chosen. So you may think that you've written an item with 5 responses. You've actually written an item where people are only using 3 of them. So it's a poor item in that there's less discrimination in this item than in a well-developed item. So what should you do with the item? Your 2 options are throw it away, but if you want to keep it, you may keep it but score it as a strongly agree, neutral, strongly disagree response. Okay? So those are not useful responses. Another useful bit of information that we get with item response theory is called the item information function. And that's similar to the standard error of measurement in classical test theory. So the more information that an item gives us, the smaller the standard error of measurement. So here we have 2 items. Item 1 has a higher, more peaked item information function, so it's giving us more information. It would lead to, if we kept this item as opposed to that item, this would lead to a more discriminating scale a scale that has a smaller standard error of measurement. Okay. So the amount of information that an item provides is maximized around that item's difficulty level. So we can match items to people's ability levels. Here we have 3 items with their item information function. The item in red is very good for people with low levels of ability. The item in blue is a good discriminator in the middle of the range, and the orange has good discrimination at high values of ability, very poor at low values. Everybody will answer this. Doesn't tell us anything. Okay.
May I ask you something?
Yeah.
In the past, let's say an instrument should ideally have these 3 examples of questions, or should be, let's say, with the yellow one, or how is the ideal combination?
Again, it all depends. If we want a scale to measure people at all levels of ability, then we want items with all 3 item item information functions. If we were developing a scale for admission to graduate school, we would choose more items over here. We don't care about this. We want to make the discrimination only at the higher end. So we could tailor the test to the purpose of the test. In most cases, we want scales that span an entire range. But this gives us the opportunity of designing a scale to discriminate where we want to make the discrimination. Okay. Don't have to worry about the equations. They won't be on the final exam. But the implication of these equations is that the standard error is related to the test information. So in classical test theory, the reliability coefficient, as we talked about, is independent of a score. It's the same throughout the entire range. This equation is telling us that the standard error depends on the score. So we could figure out, we could report a standard error for every possible range of answers on the scale. Okay? Differential item functioning. Item response theory is supposed to be sample independent. That's the theory. But we know different groups may respond differently to different items. Males versus females, patients versus those without a disorder, the original version of a scale versus a translated version of a scale. These are things we want to check. Do people actually answer the same way? And we check that with what's called differential item functioning, Diff. So, for example, males and females will probably respond about equally to items like in the past week I have felt hopeless about the future, or in the past week I felt downhearted and blue. But we know females are more likely to endorse an item like, in the past week I have cried easily or felt like crying. Women endorse items about crying more readily than males do. We know that. So we can look for differential item functioning. And there are two types. One is uniform diff, where the difference is uniform across the entire range of responses. It's like confounding. Non-uniform diff is where there's an interaction between the response and the amount of the trait, like this. So diff is very, very useful in translation. Do items have the same difficulty level in the original and the target version? Is there equal discrimination? Every few years, Statistics Canada does a nationwide survey of the health of Canada. And we were looking at the data from the mental health survey. And we found that Anglophones seem to be more depressed than Francophones. And we were wondering, is this a cultural difference? Is it that people in Quebec just drink more wine than people in Ontario? Or is it an issue of translation? So we ran differential item functioning with the English and the French versions of the scale, and found that 4 items had differential item functioning. And we looked, and it turned out they were badly translated items. Okay. Item and person fit. This is probably one of the most widely used purposes of item response theory. As I've mentioned, do 2 or more items have the same difficulty level? In which case, we can drop some items. Are there gaps in the difficulty level so that the scale isn't measuring the entire range? Can we select items to measure the range? Can we choose items to give us an interval level scale? And are there any outliers? So this is what we would get. We would get a map where we would see the distribution of items and the distribution of people along the ability and difficulty level. Okay? So what this is telling us is we have 3 items over here with an identical difficulty level. So we could drop 2 of them. And as I mentioned, if we were using the 2-parameter logistic model, we would select the item with the highest discrimination. And over here, 1 item could be eliminated. So of these 10 items, we can eliminate 3 of them and not lose any discriminating ability of the scale. Okay. We also see that there's a large gap. There are no items in the range from about a theta level of 1.2 to about 2.5. So the scale would be very poor in discriminating among people in that range of ability. So that would tell me go back to the drawing board and write some items tapping that level of difficulty. It's also telling me that in my sample, I had very few people with a very low level of ability. So I will get item statistics at the low end, but I'm not going to trust them too well because they're based on very few people.
This can be invalidate the scale? Validating the scale?
It's not validating the scale yet. It's simply telling us, is the scale measuring the range of abilities that I want it to? And are the people whom I've tested giving me enough information about items at different levels of difficulty? But it hasn't validated the scale at this point. I still don't know if the scale will measure what I hope it measures. Okay? Okay. Fit statistics, in-fit and out-fit, are also giving us information about the people and about the items. Outfit refers to people who have a low ability level who endorse difficult items, or conversely, people with a high ability who do not endorse easy items. So it's giving me a hint that either there are some people in my sample who are outliers, who are answering in a very bizarre way. Maybe they're guessing, or maybe they're illiterate, or these items aren't working very well. So, in-fit is sensitive to unusual responses near a person's ability level. And outfit is people answering far from their ability level. Okay. Uses of IRT. As I mentioned a few times, in designing scales, it could be used for weeding out items. Items that don't meet the assumption of homogeneity. Items where not all the response options are used. Where they're not used in the correct order. Items that may be answered differently by different groups and we don't want them to be. Unexpected responses and so on. A very widely used use of it is shortening existing scales. You read this all the time, at least in the psychological literature, that they've taken a long scale and reduced it considerably without reducing the psychometric properties of the scale. Adaptive testing. I mentioned the Peabody picture vocabulary test, where we have the same test, but not everybody gets the same set of items. People with low levels of ability or kids get one set of items. People in the middle get a different set of items. People at the extreme end get another set of items, but we could still equate their scores. And for high-stakes tests, admissions tests to graduate school, certification tests, we can make computer-adapted testing See, the difficulty with standardized tests is that they have to span an entire range, which means that they're long, which means that people with a high level of ability get bored answering very simple items, and people with a low level of ability are getting frustrated being challenged by items that they have no idea what it means. So we can adapt the test to the person, resulting in a much faster administration tailored to that person. So we start off with about 5-10 items from the middle ability level. So if we score difficulty or ability, let's say on a 0 to 1 scale, taking 0.5, give it to a number, give it to the people. If the people get all of them correct, then we take another set from the upper half of the item pool. If they don't get them correct, we know that they are below this ability. We only choose from the lower half. And then we keep splitting, adapting the items to the person's ability. So we could start off with a pool of 1,000 items, but only have to give 25 to get an accurate estimate of the person's ability. So, what are the advantages? If we use a rash model, we will end up with an interval scale. We can have short scales with high reliability. We get a precise estimate of the standard error of measurement at each point in the scale. We could compare people even if they take different versions of the same scale. And it allows for computer adaptive testing. So, why don't we see more of it? Forget about that. I'm giving a talk to the Journal of Personality Assessment. Harvey Weiss, misquoting Max Planck, said that science changes one funeral at a time. Right now, measurement is dominated by people my age who were trained back in the early 1700s. When we die out, we will be replaced by people trained later who are more exposed to this. So, we just have to wait. The other issue is that, until recently at least, item response theory did not come with most of the existing packages. It didn't come with SPS, still doesn't come with SPSS, it doesn't come with SAS. It now comes with Stata. I'm not sure if it comes in M+. It is available in R. But until very recently, if you wanted to do item response theory, you had to buy a specialized program, probably produced by an Australian, most of them are, which is very expensive and has a very steep learning curve. Is it needed? Well, it's widely used in achievement testing and in high stakes testing, admission to graduate school, certification, and so on. It is relatively little used in personality assessment. And the issue is it really necessary in personality assessment? Because we've gotten away with 100 years of not using interval scales. In personality testing, the absolute number doesn't matter. It's not like in medicine where the blood pressure has a real meaning and blood test values have real meaning. You can't arbitrarily decide, I'm going to change how blood pressure is measured. The numbers are meaningful. Whereas in our field, take a depression inventory and say, tomorrow I'm going to add 23 points to all the scores. Doesn't matter. The important question excuse me.
You want some water?
No. Pisco.
Okay.
The important question is, are we rank ordering people the same way? And rank ordering doesn't require an interval level scale. It doesn't require all of the sophistication brought by item response theory. So it's not used yet in personality theory. I think it will be used more in the future as younger people come along, as computer programs come along, but not yet. Any questions?
Cuando se hace ese proceso de reducción de ítems, o si yo quiero reducir la cantidad de ítems de mi escala, ¿en qué paso de la validación debería hacerlo? ¿En la prueba piloto? ¿Cuando ya lo tengo validado?
He has a scale with a big number of items, and he's in the procedure of reducing the number of items. And at what stage he needs to do that?
As soon as possible. Yeah. The problem with a large number of items is that you need a large number of subjects. That if you do anything with the items, like factor analysis, you'll need 10 subjects per item. So you want to reduce the items as soon as possible based on face validity, content validity, looking for ambiguity, things like that. Once you've eliminated items for those reasons, you may want to use item response theory to reduce even further. Reduce redundant items with the same difficulty level.
So what about using the distribution of the item? Let's say you have like a J-shaped form of the answers.
Mm-hmm.
Can you use that also to reduce it, and why? Me pregunté porque a veces tú tienes la escala, ¿no es cierto? Y tiene la distribución, es como una J. Significa que están todas las respuestas cargadas para un lado, o una J invertida. Entonces sí, también puedo usar eso como...
Yeah, one of the things that you should look for, always, is the distribution of responses. That, take the easiest example, if you have a dichotomous answer, and 90% of the people answer yes, it's not telling you anything. You might as well drop that item. If you have a 5-point Likert scale, and everybody says strongly agree or agree, it's not telling you anything. The distribution doesn't have to be normal, but all of the response options should be used. If they're not all used, the question isn't discriminating. So yeah, you could definitely use the distribution to eliminate items.
Me queda claro en qué parte del proceso de validación uno puede aplicar esta discriminación de ítem.
he's not clear about in which part of the process of discrimination he can redact the items, where in the pilot study or later on.
How many people are in your pilot study?
¿Cuántos tiene el piloto?
100 personas.
100.
That's fine. I would make a lot of decisions based on that pilot study. It's a nice size. You would get a good estimate if all of the response options are used. It's not enough for item response theory.
Dice que puedes obtener una buena estimación si todos los ítems son respondidos, pero que no es una buena opción para la teoría de ítem-respuesta. ¿Quieres saber por qué?
Que me interesaba más para poder acortar la escala, porque son muchos ítems y está diseñado para la investigación más que para el diagnóstico clínico. Entonces me interesaba tener una escala, que son muchos ítems, para el proceso 900, una vez lo vimos con el profe Luis, justo hace un año. Entonces, esa cantidad de ítems es una herramienta muy poderosa para lo que es la investigación, pero para la clínica son muchos, hay que acortarlo. Eso es esa es mi pregunta. Si yo quiero acortarlo, ¿lo puedo hacer en mi prueba piloto o lo tengo que hacer cuando ya tenga la escala validada?
Lo que él te dijo, lo antes posible. Porque en el fondo, durante el piloto te dijo que era suficiente. Sí, 100 personas era suficiente, pero que tenías que tener respuesta en todos los ítems idealmente, pero esto no era útil para item response theory, o sea, para la teoría de item response. Le pregunto por qué.
¿Ya?
I would like to know why this is not suitable for item response theory.
Oh, it is. You can.
Sorry, I understood that it was not.
No. Once you get some more subjects.
Okay, 100 is not enough for item response, but then he can get a few more subjects, then he can apply that.
Oh, absolutely.
Entonces, al principio con 100 no es suficiente, pero una vez que aumente un poco el tamaño, sí se puede usar.
How many response options do the questions have?
¿Cuántas opciones de respuesta tiene las preguntas?
Dicotómica.
They are dichotomous.
Dichotomy. Oh, good. Then 100 may be enough. See, the sample size depends on the complexity of the model.
El tamaño depende de la complejidad del modelo.
So a 2-parameter model needs more subjects than a 1-parameter. A
¿Un modelo de 2 parámetros? ¿Entiendes?
Sí, no se entiende.
3-parameter model requires more than a 2-parameter. Polynomous items, multiple response options, require more subjects than dichotomous. So if you have dichotomous items and you want to look at a 1-parameter model, 100 people may be enough.
Incluso para 900 ítems.
Even for 900, ¿tiene 900 ítems o 900 personas?
No, son 100 personas para la prueba piloto. De una prueba con 900 ítems.
So even though they have 900 items,
Боже мой.
¿O hay algún tipo de relación entre la cantidad de personas e ítems para
or there
que
any
funcione
ratio people items?
No.
For these to work.
Sí, pero es
No.
una variación.
No, item response theory depends on the complexity of the model and the number of response options. The sample size isn't determined by the number of items.
Ah, ya.
Okay. Are the people still awake after 900 items?
I think that because I asked whether they were 900 items, ¿estás seguro que son 900 ítems?
Sí.
¿Para qué cosa eso?
Es para el instrumento.
Porque él preguntó si la gente todavía seguía despierta.
900.
Sí, porque eran. Bueno, es que como ítems son 400, pero como son respuestas dicotómicas, son 900 respuestas.
Ah, la respuesta no.
Ah, entonces, No, pero los ítems no es lo mismo que la respuesta, es
claro.
cuántas preguntas tiene y cuántas opciones.
O sea, el ítem sí, son 460 preguntas con 900...
No importa. Pero son 460 preguntas escúchame, pero ¿esas se le aplican a todos o van siendo aplicadas, como él decía, que de repente selecciona un grupo y se responde en positivo, entonces va a otro grupo?
No,
¿Cómo?
todas.
¿Ah?
Todas.
¿Cómo se llama la escala? De 400 escalas de ítems, no sé.
El inventar el desarrollo comunicativo.
He's saying it's 400 items.
Okay.
MacArthur Bates es conocido, como lo conocen.
¿Cómo se llama?
MacArthur Bates.
Colócalo ahí en el... ¿Tenéis cómo? Ahí. ¿Qué son 8 horas?
400. ¿Toda la mañana hasta eso?
Sí, pero son todas las
¿No
cosas.
son 30 minutos?
Sí, no.
Bueno, la primera es la página del instrumento.
La segunda es esa, a ver, tírala ahí.
Esa es la página del... Bueno, o sea, ¿ustedes quieren ver como el instrumento como es?
A ver.
¿Dónde está el latino acá?
Aquí está English and Spanish form.
Pero es que pusiste como
Scoring program.
Do you have some examples of the questions?
La parte más poderosa del instrumento es la lista de vocabulario.
Es que tiene entonces muchos dominios. ¿Cuántos dominios?
Que son 3 dominios.
¿Tienes
3 dominios.
ejemplos de preguntas?
Por ejemplo, es un poco la palabra coche, ¿la comprende o la comprende y la dice?
There are 3 different domains.
3 dominios, ¿no?
Sí, es más que nada que son 2 grandes y el tercero está como en discusión. Es lenguaje comprensivo y lenguaje expresivo. Eso es como lo grande del instrumento, los 2 grandes dominios.
The big 2 domains are comprehensive language or expressive language.
Yeah. Those would probably have to be analyzed separately, because don't forget, the main assumption in item response theory is unidimensionality. So if you have different domains, each domain may be unidimensional, but put them together and it's a multidimensional.
¿Entiendes? ¿O no? ¿Ah?
Per cada dominio.
Claro, para poder usar esta teoría.
Sí.
Now,
porque es unidimensional nomás.
they say that there is a short form available. So why would you want to shorten it again?
Porque la versión corta está hace 2 años atrás que lo realizaron en México, que es la que yo quiero validar, y hay mucha evidencia sobre sus propiedades psicométricas, que no han sido muy buenas en la versión corta. En cambio, la versión larga, todas las propiedades psicométricas son súper altas.
The shorter version doesn't have a good psychometric property, he's saying.
Okay.
It was developed by Mexicans.
Ah, well, that explains it.
Tequila and so.
Yeah. It's not pisco. Yeah, okay. But yeah, just remember you have to analyze each domain separately.
Entonces,
Es como si fuera una escala, cada una. Esas fueron una de las primeras cosas que dijo él.
May I ask something?
Mm-hmm.
Would you say that this, because as I see it, the main difference between this, the item response theory and the classical testing theory is that the questions shall be more precise in order, because we are trying to avoid sample size issues and also to have multiple domains. So probably it's a way of simplifying evaluating constructs or something like that, no?
No.
It's a very simple question probably, because I'm trying to see what is the main purpose of developing an alternative theory of building assessment instruments if there were already one that it works. So first I thought, okay, probably it's because they need a shorter a smaller sample size.
No.
Compared to the other, what is the, because at the beginning you compare them.
That's right.
So the purpose was to be able to develop studies with less complexity, no?
No. No. Yeah, these are the difficulties with classical test theory. The sample dependency, the circular dependency, this is a main problem, assuming that all of the items are equivalent and the equivalent of the standard error. So it's trying to eliminate those problems, trying to make it easier to equate tests.
Between languages, for example.
Between languages, that's right.
Okay.
Yeah, it's much easier to establish the similarity between English and Spanish versions of a test if they were developed with item response theory than with classical theory.
So then validation shouldn't be that complex.
Well, it would still be hard, but it's easier.
Closer.
Yeah.
Okay, thank you.
Aquí está.
¿Tienes
Ahí está.
¿No lo tiene en inglés?
Cierra.
Está separado por subsecciones, pero es como una forma de agrupar el lenguaje, que lo más importante es ver lo que es comprensión y expresión.
Muestra una parte nomás para que no...
Sí, quiero mostrar. Esta es la parte como más grande, que es la lista de vocabulario, que son un montón de palabras, y eso va entregando un cierto puntaje.
Okay, can we see some other parts of the test? So this is just, can they identify different animals?
Comprende.
Yeah. Okay.
Esos son animales que están ordenados por categorías semánticas.
Okay, so this is all vocabulary.
¿Quién responde eso? No me acuerdo.
Estos son los padres.
Los papás.
El cuidador.
Parents answer this. About the boy.
Y eso es la...
Tengo una comida típica.
Sí, por
Okay.
ropa, Bueno, esta lista es súper larga, por eso es que una de las ideas es abortarlo un poco.
Okay. But this is still all vocabulary.
Most of them. Esto sí es un vocabulario. Después vienen acciones y verbos. Eso ya te sabe un poco de lo que es el vocabulario. Estados, que son preposiciones.
Okay.
Cualidades. Bastante largo, gracias. Una pregunta, sí. Son todas, está separado por parte, o como uno puede pensar el lenguaje, pero lo que comprende, luego lo que comprende, luego produce y la segunda parte del inventario no es vocabulario, pero también es lenguaje demostrativo y específico.
Son todas como subescalas.
Por eso me un poco interpretar que eso no es que sea dicotómico, incluso puede ser ordinario. Porque si uno a determinada edad ni siquiera comprende una palabra, no lo puedo aplicar. Como el uno, no sé. Entonces a lo mejor es ordinario.
No sé.
Está por el tubo.
Juega tortillitas, peor.
No sé, estas palabras que no se nos mueven.
Juega tortillitas.
Y que estos niños mexicanos son muy...
No sé, hay más de una situación que yo para pensar.
That's the reason why I was asking you the other day about inventory of things. Do the children do this or not?
It's close.
Huh?
It's close. Yeah, this is sort of at the border between an inventory and a scale. But with vocabulary, for example, they're supposedly in order. So it's
an increasing
difficulty, that's right. So it's not just an inventory.
But the instrument is called inventory.
Forget what it's called. It's a scale of vocabulary or language skills. Yeah. Okay.
La pregunta es, eso está en las preguntas, por ejemplo, sube un poquito en el, hay mucho. Sigue. Esa, colócala completita porque tiene ahí el set.
No sé cómo se sabe.
Pero con la tecla no funciona. No te vas. La set. coloca la C completa. No lo veo completo la sección C. La sección C. Sigue, la quiero ver completa porque tiene como hasta ahí. Ahí. La pregunta es, ¿esto está en orden de dificultad o no?
En ninguna parte leo que
no, porque... ¿Ah?
A mí tampoco me parece. Creo que son preguntas ordenadas, pero no, o sea, no en orden.
Pero se pone el teléfono en la oreja es más difícil que se pone un zapato, ¿o no? ¿Hay algún tipo de orden? ¿No? ¿Seguro?
Yo estoy prácticamente seguro porque la verdad que esto es de 8 a los 18 meses. Entre los 8 a los 18 meses, o del año a los 2 años, la curva de lenguaje y de habilidades motoras es súper similar. De hecho, el pic del lenguaje empieza como a decaer al finalizar los 2 años, empieza a aumentar el lenguaje.
Yeah.
Pero no es como un orden que uno puede hacer.
I was asking whether this is ordered by level of difficulty.
It looks like it is. Yes. It looks like it's.
Luce como que si fueran las preguntas de acuerdo al grado de dificultad. ¿Ah? Seguro.
Estoy prácticamente seguro, pero me sembró la duda.
Claro, porque el chiquito come con la cuchara, está bien, pero es mucho más fácil que tírame la pelota. I think it's not ordered.
Okay.
Pero tienes que tomarlo por separado, definitivamente.
Como comprende y...
Claro. Son como si fueran diferentes escalas en una, como le llamaban la super scale. It looks like a super scale, different scale.
Yeah.
Y para entonces utilizar la teoría de respuesta al ítem tendría que ser dominio por dominio. Si quiere usar, if you want to use SEM, he will draw the whole picture. Huge,
Yes.
you will need a computer like this.
Yeah.
With a screen.
Yeah.
Ok. Desafío. ¿No? Con él. Una más, ¿cómo estás tú?
So, is that it?
¿Estamos en la ronda de preguntas, parece?
Sí.
Bastante trabajo te espera.
Yo creo que van a hablar el tema que sí. Eso es lo que más cambia.
¿Tú eres psicólogo o médico?
Vine hace rato ya investigando un poquitito, pero con el profe se me ha aclarado mucho más. O sea, todo lo que había estudiado antes lo he visto en el magíster, en algunas clases, pero lleva un trabajo atrás que tampoco es oficial, como para decir esto no lo voy a hacer. Lo voy a hacer, pero quizás no para el magíster.
Como una línea de trabajo.
Claro, si sea muy largo.
Sí, eso estaba pensando.
Okay, ready?
Yeah. Sí, ready.
Okay, thank you very much, David.
Thank you.
Bueno, ya tienen el correo, también dijo que está dispuesto a...
Las presentaciones ¿no?
Sí, las vamos, sí, Mauro me las pasa y yo se las hago llegar. ¿Firmaron la lista?
Sí, la encuesta hay que llenarla.
Ya.
Mauro, Mauro. ¿Tú tienes las dos? ¿Me las mandas a mi correo, por favor? ¿Cómo que no? ¿Cómo que no? Sí, ahí las pido Richard para ponerla en el computador.
Richard la debe tener.
¿De dónde está? Sí, las dos te debe ya.
Entonces la debe...
Porque dijo que le iba a estar intercalando. Al final no lo dijo.
Sí, seguro.
O sea, sí, la pizza.
Eso. Se acabó la ronda de preguntas.
Ah, ya, terminamos.
Sí.
Porque...
No, ya, eso
Tenía
es
previsión.
Sí, se me preguntó.
¿Y la lista de asistencia también?
En la mañana quiero una hojita.